continuing with the fantastically exciting terminology section.
So let's see. We made it through. We did. We made it all the way through discrete continuous. Yes. Okay. So remind me real quick. The number of kids somebody has. Discrete or continuous? Yeah. You don't want to go to the house with a 2.7846 kids. What? So what about temperature outside? Continuous. So you don't think about how would somebody normally say it. Nobody would ever say, man, it feels like it's about 71.846 degrees outside. Nobody would ever say that shit, but could you measure it more precisely and it continuously makes sense? Yes. Can you measure the number of beetles that are on a bush more and more precisely? No. There are 7. Be more precise. Who are you? You guys kind of with me? So number of is very often a very good key word for discrete, because then it's countable, which is the main idea of discrete. I like it. Maybe. So if I said the average number of politicians who lied was 142.79 something, right? Is that continuous or discrete? All right, a few people that said something that said discrete, which is right. Don't look at the number and say, let's go to decimals, continuous. That's not what continuous means at all, right? Plus, number of politicians. That's what I'm keeping track of, right? So that would be discrete. I can count them. Why is this a decimal number? Because it was an average. So you don't look at the number. You think about what the data is I'm collecting. Don't look at what I did with the data. Think about what the data was. If I said the tallest guy was 7 foot tall, is that continuous or discrete? Continuous. Yes, you don't say 7's a whole number, Jeff. So it's no. Height of a dude, I can measure more and more precisely, right? You guys with me a little bit? And the decimals, and I can just keep going as far as I want to in the decimals, and it just keeps making sense, right? But if you said I got 3.0000000000000 fish, what? Who are you? You got 3 fish. You guys kind of with me a little bit? Kind of? Okay, enough of that. So. Let's do this. Let's do this one first. This is maybe a little more interesting first. Please don't ask me what section I'm in. I have no idea. This is chapter 1. So sampling technique. So we did talk about what a random sample was, right? And that's always your goal, is to try to get a random sample, because that means that's the one you can trust the best. What's a random sample do? What's it supposed to accomplish? What do you guys think?
Everyone or everything the same opportunity.
So that's how you pick a random sample. Everybody in the population or everything has an equal chance to be selected. So if you're starting to pick a sample and there are people that can never be in the sample that you're trying to describe, you better stop. Something's wrong. Nobody can ever trust your stuff. But what is it trying to, why do I do that? What am I trying to do?
To be
representative of the population. I love it. So in order to be representative of the population, everybody has to have an equal chance to get in. Kick ass. Okay, I like it. So let's get a little bit deeper into how I can go about doing that. One way is, let me do this one first. It's called systematic. Jeff, there's a T there. Systematic. Systematic is pretty much exactly what it would sound like. There's a system to it. So if I took every 8th fan off the assembly line at the fan factory, that would be systematic. If I took the temperature every 11 minutes, if I stopped every 3rd person that walks by me, that's systematic. So what's the key phrase in there? Every nth. Every nth thing, every nth minute, every nth whatever. So that one's pretty much in your face when it's systematic. I like it. Now what's wrong with this method? When would this method fail maybe? This is a little bit of a weird question, but I gave it away with that fan thing. If I took every eighth fan off the assembly line, no, not necessarily. All right, so I have a very cartoonish way of thinking about a factory. So there's this big machine, and it goes ka-chunk, ka-chunk, ka-chunk. You know, like maybe putting caps on bottles, right? You with me? I'm pretty sure that's the same way it's still done. But let's say like this thing has 8 sides to it. On one side, it's gotten broken. So every 8th bottle is not going to be correct. So if I take every 8th bottle as a sample, I'm like, holy shit, everything sucks. Every single bottle I picked sucks. So systematic is not good to use if there's something cyclic in your process. Does that make sense? So I wouldn't use it on like an assembly line because that might just point out that, you know, not everything's bad. Just one piece of it's bad. So I'd have to use a different sampling technique to get a better representation of the population. Maybe. Okay. Let's do the next two together. There's one called cluster and one called stratified. Become an F. Both of these start off the same way. So they both break the population into groups. Step 1, break pop into groups. So I'm just imagining like 3 classrooms of people or something. Cluster is exactly what it sounds like. What would it mean in a cereal if they say some kind of cluster? It doesn't mean it has little honey nut clusters, right? Where they all cluster together. So cluster is what it sounds like. I take entire bits and take everything from that. So cluster would be randomly pick groups and take everybody from that. So if I randomly selected 2 classrooms on campus and took everybody from those classrooms, that would be a cluster sample. All from some. Very Three Musketeers sounding thing. Then you take all from some to be in your sample. Does that make sense? So everybody in here goes into the sample. I like it. That is still random. If this is my entire population, did everybody have a chance to be in the sample? 11 people say no because you're looking at the sample. Not everybody's in there. If everybody was in there, it'd be a freaking population. So did everybody have a chance to be in the sample? What did I do? Why did I pick those 2 randomly? Could that have been picked? Yes. Is there anybody I would have left out? No. Do you guys see what I'm saying? So these 3 are random. They're just more specific ways to do random sampling, right? So if you 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the back, right? So there's 10 groups of people in this room. Are you with me? The rows? So if I randomly selected 3 rows and took everybody from that row, that's cluster. Stratified says, that's nice. I want everybody to be represented, and I'm going to take a few from each. So some from all. Some stratified. Some stratified. Some from all. That's stratified. You guys, I don't know if you guys know what strata is. Strata is like in geology, you can see the strata of the rocks, right? So it sort of like goes throughout everything. So it kind of like touches everything. So I take some from all. When would you want to do this kind of thing? When would this kind of thing suck? I don't know. It's kind of a wide open question, but
I'm trying to figure out which of your classes is the most attractive in this list.
yeah. So anything where I love it. That's awesome. Anything where these people's voice wouldn't be heard and they would be upset about it, right? So for example, if you're at a high school and you're like trying to sample students to see what their opinion on something, and you pick all the freshmen and all the seniors, the sophomores and the juniors, man, what the shit? So you'd rather do this, wouldn't you? Stratified. So then you have representation of all the groups. I like it. So that's why there are different ways to do this, because there's different reasons to do things. You want to try to make sure everybody's represented, do this. If this would be something like, take all the patients from randomly selected hospitals to see something about their care, right? I mean, that could be true. Or take everybody from zip codes somewhere where the geography doesn't matter. I mean, that's where you might want to use this. Stratified is if you want to make sure everybody feels like they're represented, right? Going back to my rows thing, if I took one person from each row randomly, that would be stratified, because all the rows have something in the sample for sure. Okay, maybe. Not too bad. Then on the side here, let me put, there is, of course, situations where it's just, yes?
It seems like the stratified and cluster are really different based on how the chunks are selected, whether the chunks are kind of randomly sorted, or if the chunks are sorted based on some characteristic themselves.
Oh, the way you break the population up into groups can be any way you want to. You just have to be careful that you don't introduce bias by, like I said, there will be situations where this way would suck, especially if you break the population up into groups in a certain way. So the way that the population is broken into groups is itself up to you. It's right. So if I took every student with a last name of C, F, R, and W, you with me? I just randomly select letters. I took every student with that last name in a sample. Do you think that would be okay? This is a very interesting question.
Depends on what you want to study.
Yeah, sort of depends on what you want to study. Okay, I like it. But these are options that you could use to create samples. I like it. Each one of them has problems. So you just have to pick the one that has the least problems. This would be if there's no real system to it. If I just put everybody's name in a hat and picked out names, that's none of these. Right? You with me? Okay, I like it. So that's random. I mean, I'm not going to write it. What are you talking about? And this guy is kind of like the odd guy out. This is the sucky one. It's called convenience. Sucky is a technical term. Convenience. So again, this would be like if I used you as a sample to represent all of Grossmont. I'm not saying you are sucky people, but why would you be a sucky sample? Why would it be bad? Yeah, there would be biases. Why are you here? You're here. You're able to be here at 7. Is everybody able to be here at 7? No. You're taking statistics. Does everybody have to take statistics? No. There's all these kind of built-in prejudices against people. Not everybody could have been in this class. You guys kind of with me? That's convenience. I didn't even try to make it random. That's what makes it convenient. Right? I like it. Okay. All right. So I personally find that more interesting than what we're about to do, which is a horrible thing to say, but too bad. The next thing, you're going to have to be able to still do it. Any questions on these before I move on? Okay. Almost done with the definitions. Just stick with me. We're going to get into some data analysis today, which is nice. And some of you guys are like, we don't have to, man. Yeah, we sort of do. This one's called levels of measurement. So this is kind of breaking down the types of data that we're going to work with. What are the two main types of data, the keywords? Qualitative, quantitative. But like a qualitative basically is not numerical, purely categorical. Quantitative is the true numbers. You can do math stuff with them. Quantity, they actually measure something. So the first two of these are, for the most part, qualitative. And the second two are, for the most part, quantitative. So when I ask you what level of measurement would this represent something, you first think to yourself, is it numerical or not? If it's not, it's one of these two. If it is, it's one of these two. That's the first thing you do, so then you break your choices down from 4 to 2. Right? It's a really smart way to do this. The most basic level is called nominal. You guys ever heard of Stephen King?
The congressman or the author?
Huh?
The congressman or the author?
Yeah, I appreciate that. And there's a lot of Stephen Kings out in the world, but the Stephen King, the one that most of us know. What was, when he first wrote books, anybody know he didn't go by Stephen King? Do you know that? If you love Stephen King and you've never read any of some books written by somebody called Richard Bachman, go read those, because that's what he called himself first. Right? That was what, anybody know what that's called? It's kind of French, fancy French name when you use a different name.
Pen name?
No.
Yeah, pen name, but in French. Plume de nom. I don't know if you guys, plume de nom. And you're all like, this shit class is this, this stats. Plume de nom, nom, name. Nominal name, not number. You ain't got shit to do with number, right? Don't say it's number. No. Nom, name. So this is truly just name data. Like if I recorded everybody's hair color in the class. That is name data, right? Can you subtract blonde minus brunette? No. If I said red, blonde, would you go, whoa, that's out of order? No, I can list them whatever order I want you. They're just names of hair colors, right? So that would be this. This is just name data. Example, hair color. The second one is still names. So what's going to happen as we go through this list is every step is just going to get a little more complex. It's going to add something to it. So everything is at least nominal. But some of them might be this next thing also called ordinal. And what seems to be the main idea of that word? Ordinal. Order. There's got to be a certain order they must be in to make sense. Not just I put them in alphabetical order or something, but there's an order they have to be in to make sense. There's what's called an inherent, Jeff, order. Everybody's cool with the word inherent, right? It's in it. It's something that it itself sets up. So what the hell would be an example of this? Have you guys ever filled out faculty evaluations? But you can imagine, if you've never done it, at the top it says 1 through whatever, and it says strongly disagree, neutral, agree, strongly agree, right? For every one of these statements, your teacher knows this shit, whatever. And then you strongly agree, disagree, whatever. If they would have put that agree, neutral, strongly disagree, wouldn't you have gone, what the shit? You trying to trick me? You guys with me? If they would have put that out of order, you would have stopped and went, oh, are they, what? Are they trying to trick me, putting this shit out of order? Do you guys understand what I'm saying? Mm-hmm. Isn't there an order those words have to be in for it to make full sense? So they are just freaking names of how you agree or disagree, but they have an extra thing. There's an order they have to be in to make sense. I love it. That's what ordinal is.
The ordinal data is also nominal data?
Beautiful. Everything is also everything below it. I think about it roughly as like belts in judo or something, where if a black belt can beat a white belt, whatever. So the highest thing is also everything else. So when I ask you what level of measurement is this, you give me the highest level. You don't list all of them or something. You just give me the highest level it is. Okay. These two, again, are truly numerical things. This would be called interval. What is an interval in algebra? Anybody remember interval notation? You guys remember that? You guys doing all right? I'm trying to black that part of my life out. Dang. What's an interval in English? An interval of time. What does that mean?
15-second intervals.
50, okay, there's like a length to them, right? How do you get 15? If it was from time 11 to time 26, how long was that interval? 15 seconds. So it seems like the main idea of this should be subtraction makes sense. You can figure out a length. There's a subtraction makes sense. Not just can you subtract. Can you subtract 2 zip codes? Can you subtract? Of course you can. What's 91941 minus 90220, whatever? I can do that. Does the answer mean anything? One semester I had a bunch of people from the women's basketball team, and I said, if you subtract Michelle's jersey number from Tanya's jersey number, it doesn't make any. And they're like, oh, we get Barbara. Because it was, it was 14 and 11 and 3. I went, oh, shit. but so that wasn't the best example. That was really, really funny. But yeah, jersey numbers. I can subtract them. The answer doesn't mean anything. You guys with me so far? So a good example of what would be interval is like the temperature. Like today it's supposed to be, 7 degrees cooler than it was yesterday. I subtracted today's from yesterday's. You with me? And it makes sense. It actually makes physical sense to say to somebody what that is. If I subtract 2 Social Security numbers, the answer doesn't mean shit, right? Can't like it, maybe. So that's interval. So an example of this would be temperature, let's say degrees Fahrenheit. You'll see why I say that in a minute. Anything else? Year of birth. Right, if I subtract 2 people's year of birth, that tells me what?
How far apart they are.
Yeah, how far apart they are in age. Right. How much different time they've been roaming the earth. The last dude, the name gives it away, hopefully. Ratio, when you hear that, what operation do you think of? Division. I love it. So this is where division also makes sense. Now what's interesting is what allows that to happen is the second thing, is that 0 means what it's supposed to mean. Not just that there is a 0 in the data, but that it means what it's supposed to. If I say it's 0 degrees outside, does that mean the absence of energy? No. Can you get colder than the scale of temperature we use? 0 degrees Fahrenheit. Can you get colder than that? So does 0 on the Fahrenheit scale mean what it's supposed to? The absence of what I'm measuring? No. If I went out and tried to catch some fish and they said, how long was the longest fish you caught? And I say 0 inches. What's that another way of saying? Got no fish. Right? So 0 would mean what it's supposed to mean. So most measurements would be ratio. Temperature is one where they put 0 in the wrong place. How many temperature scales do you guys know? Yeah, some of you guys know 3. It's okay if you don't. Don't feel bad. There's Fahrenheit, Celsius, Kelvin. You don't have to suddenly know Kelvin, but just to let you know, Kelvin is a true measure of energy. So when you get to 0 Kelvin, you're dead. Everything's dead. It's it. We had a good run, right? That is the absence of what it's measuring. You guys see the difference there? So again, something like number of kids, if you have 0, you have no kids. That's what 0 means. So it means what it should. Now, this idea of division makes sense. If somebody has 2 kids and somebody else has 6 kids, 6 divided by 2 is 3. Does that mean something? What's that 3 mean? 6 kids? 2 kids.
Yeah.
6 divided by 2 is 3. This guy's got 3 times as many kids. It makes physical sense. That's what it means when I say division makes sense. Can I divide people's year of birth? Can I divide it? Yes. Will the answer mean a damn thing? No. Do you understand the difference there? I mean, that's not just can you divide the shit, but does the answer mean something? That's what makes it ratio. Okay. So I'm hopeful. All right. You got to get in there and try those problems out. I like it. Yes. You're good. So let me give you an example. What about, what about the number of stars you give a restaurant? From 1 to 4.
Does it matter that there can't be a 0?
It does matter. There can't be 0. Would you argue that is interval? What would that mean? Did you do 3 stars minus 2 stars and get 1 star, would it really mean something?
No.
Not really. So it's definitely at least ordinal, right? You would say a 2-star restaurant is a little worse than a 3-star restaurant. The order makes sense. There's got to be an inherent order for it to make sense. You guys kind of with me? But you see how there could be. So for example, what about the number you take at a deli? Take a number at a deli. Yeah, okay. Now watch. It is nominal, but that's not the answer yet. It is nominal because I could be number 7. You're number 7. That's your name. That's all I see you as number 7. Get your ass over here. What do you want? Ordinal. Why would ordinal? I mean, what's the basic idea of taking a freaking number at a deli? Put everybody in order, right?
Couldn't you say it's interval?
Ah, okay. Why?
Because I got 33 and he got 37. That schmuck's 4 behind me.
I love it. Who's this poor guy? All right. You have somebody in mind? Yes, so what I want you to realize is when I give you the quiz, I'm going to ask you what level of measurement is this, explain. Because there are some problems where I will accept a couple different answers based on how you look at it. My real purpose is to make sure you understand what the words mean and how to apply them in a real life situation. So some things will have more than one answer based on how you look at them. For that situation, though, nominal wouldn't be an answer. Because there's more to it. There definitely is. So I would take ordinal or interval based on how you looked at it. I like it. You guys kind of with me here? Mm-hmm. A little bit? Okay. All right. Okay. I think I told you this already, but I'm not going to talk about section 1.4 at all. It's up to you. You guys read it, do the homework. Let me know if you have questions. Sorry. Just to make sure you realize that book plus me equals class, and then other stuff equals better class. If you find anybody ever use YouTube videos to help? Some of you guys? What do you use? Do you use like a standard thing or
Crash course.
crash course? Interesting. I like it. I've never heard of it, so I'm gonna have to look at it. Yeah.
Sometimes certain problems are on Khan Academy.
Khan Academy. Have you guys all heard of Khan Academy? Mm-hmm. Okay. He's getting a little too out there. They want to set up entire courses around it. I'm like, just calm down, dude. Khan. All right. Thank you. And now, if you search through YouTube, you're going to find a lot of crap, but you will find some things that are really good. So if you find a person that makes sense, see what else they talk about. So you go to YouTube, just type in an idea. Type in level of measurement and statistics. And then you can just kind of watch a few different videos. You feel like I'm tired of listening to Jeff. He's not making a damn bit of sense. Let me see if somebody else makes sense. Awesome. I love it. So let's get into chapter 2. So there's two main things we're going to do in this class. We're going to talk about descriptive statistics first. And it's pretty much exactly what it sounds like. If I take a sample, I want to describe what I see in my sample. I can do it orally, I can just talk about it, I can do it visually, I can do it computationally, I can do it whatever. So this is descriptive statistics. It's just what do I see in my sample. So I can make a bar graph, I can calculate an average. All those are descriptive statistics. Later we're going to do something called, this one certainly sounds harder, inferential statistics, where I'm going to take a sample's results and infer something about an entire population. That's where things get a little more useful, but also possibly misused. Right? Well, we'll talk about it when we get to it. So, descriptive statistics. We start off really nice. Enjoy this while you can. We start off with, let me put this here. Graphical methods. The first thing we talk about is called, yeah, Jeff, I'm against vowels today. Stem and leaf plot. I think the book just calls it stem plot. So stem and leaf. So let me write down the most basic example I could do. just so we can get the idea of this. So here's some data. Okay, so write that data down. It's going to be a lot of lists of data. Data entry jobs. No thank you. So stem and leaf refers to a quick way to put the data in order. I gave it to us in order already just to bypass that. And to get a quick visual of it. The stem part is kind of like the first digit normally. So 4, 5, 6, 7. Smart cart's going to drive me crazy. Did anybody see that? And then the leaf part, it kind of makes sense. What comes off of 4 in my data? 1, 7. Kick ass. Did I do any commas? No. Let me just try to nip that in the bud now. Not a big deal, but no commas. And there's just the convention. So what comes off of 5? Good.
4.
So you do show repeats, and you'll see why in a minute. You want this to represent all your data. And then 6 would be 1, and 7 would be 2 and 6. Now, if I ask you to make a stem and leaf plot, or if the book asks you to make a stem plot, this isn't done yet. Because this could mean 4.1, 4.7. Of course, we know it doesn't because we saw the data. But normally, this is all somebody's going to see from us. So I have to put a key so people can read it. Does everybody see that? If the data was 4.1, 4.7, the stem and leaf plot would have looked exactly the same. My key would have been different. This could also mean 410, 470. It just depends on what my data looks like and how I want to put it up here. So the key for this one would be 4/1 equals 41. So if you don't put the key down, it's not complete. Is that difficult? No. Enjoy that. And watch, this is kind of cool. If you turn your head like this, you see kind of how the data is distributed. If these are ages, where does there seem to be the most people? How old are what's the most occurring age group? 50s, right? So that's a remarkably quick way to get a rough visual of the data. All right, I like it. That's all I'm going to say about that because it's really not that freaky. Then there's something called a, this is obviously for numerical data. We have something called a bar graph. Everybody in here has seen a bar graph. I'm going to take this away. Bar graphs are for really any kind of data, but primarily for qualitative data. And what do I mean by that? Not only qualitative, but if I had this kind of a bar graph, let's see. What's going to make sense here, Jim? Sure, why not? Yeah, sure, 10, 20, 30, 40, 50 percent. Let's see, 50, 80, 20. Okay. Unsure, I think that's that word. That's a bar graph. The scale on this is qualitative. Is there actually a scale? If I would have put unsure, no, yes instead, would you have freaked out? Not really. So it could be ordinal, but normally it's just nominal data, just names of stuff. I like it. Maybe, maybe. So that's not what we're going to focus on, the bar graphs. We're not going to focus on those. We're going to focus on the quantitative analog to that. The histogram. Okay. histograms, since they're going to talk about quantitative data, truly numerical data, then there will be a real scale for that x-axis. Yeah, you do. So for example, all right, let's take up, I do have a worksheet. I will eventually shut up today and let you guys do some work. But a histogram is going to look like this. So this is ages. How many people were between 30 and 40? Yeah, 5 people, right? Got to give me board license here. Everything gets skewed when I'm right up on top of it. How many total people did I talk to? 12 total people, right? So this scale, what does this one represent then? Obviously, it's got to represent the number of people or things, right? In this case, people. And this is whatever I was measuring about those things or people. Okay, I like it. So let me give you the sheet. First I want you to do one side of the sheet, which goes all the way up until I give you one of these that's made for you already. And then we're going to talk about how to make these ourselves. And then I'll make you make one. Let me give you this. So I want you to work on the side that's got the blue boxes at the bottom. Cool. Don't worry about the other side yet. We haven't talked about that yet. Sure. Feel free to help each other out a bit if you want. Yeah. That's going to be one little point I want to make for this, yeah. So again, you could